Hello students. In this lecture, we will talk about Euler's method, which is again a single step method like we have done in the previous lectures, Picard's method and Taylor series method. It is also known as forward Euler's method. This is the most simple method to solve the first order differential equation of the form dy by dx is equal to f of xy with the initial conditions y at x naught is equal to y naught. It provides the solution at the current mesh point in terms of the solution at the previous mesh point. That means if we wish to find out the solution of y1 at x1, then we can calculate it using the initial point x0 and y0. So the formula to find out the first approximation y1 is given by y1 is equal to y0 plus h times f of x0 y0. Similarly, we can calculate the next approximation y2 using the formula y2 is equal to y1 plus h times f of x1 y1. Next approximation is y3, which is equal to y2 plus h times f of x2 y2. Proceeding in the similar way, we can generalize and we have the formula yn is equal to yn minus 1 plus h times f of xn minus 1 comma yn minus 1, where n ranges from 1 to up to infinity. So it has certain drawbacks. This method is very slow and it has large errors. So how we can achieve accuracy? To remove such errors, we should take our edge to be as small as possible. How we could take that? We can assume the n to be very large. That means the number of subintervals. So we can calculate our step length h using this formula xn minus x naught upon n. So n is the number of subintervals, x naught is the initial point that is given to us in the question, and xn is that point at which you have to find out the value of y. So moving ahead with the questions, we have this first question. Using Euler's method, find the approximate value of y at x is equal to 1, where dy by dx is equal to x plus y, with the initial conditions y at 0 is equal to 1. So here we have x naught as 0, y naught as 1, xn is equal to 1. As I told you that xn is the value at which you have to calculate the value of y. Also f of xy is equal to x plus y. H would be xn minus x naught by n. So here I have assumed n to be 5. It should be large enough so that I can calculate h to be very small and it will give me less errors. So h is coming out to be 0.2. I have to find y1. So using the Euler's method, I have created a table of the values of xi and yi's using this formula that y of n is equal to yn minus 1 plus h times f of xn minus 1 by n minus 1, and I'll substitute the various values of n here. Now, how could we find out the first value? That is, for n is equal to 1, y1 would be equal to y naught plus h times f of x naught y naught. Y naught is given as 1, h we have calculated at 0.2, f of x naught y naught is x naught plus y naught. So I am getting my first approximation. Y at 0.2 is coming out to be 1.2. So here you will see in this table, I have created the x values. This is x naught and the corresponding value of y naught. This is x1. What is x1? x1 is x naught plus h. So 0 plus 0.2, it will give me 0.2. Now, how would we calculate y2? y2 would be y1 plus h times of f of x1 y1. Now, y1 is 1.2, we have already calculated. H is 0.2, f of x1 y1 would be 0.2 plus 1.2. So, in this way, I would calculate my next value, that is y at 2 in this table, which is coming out to be 1.56. Now, x2 is again, how would we calculate x2? You just have to add h to x1 and you will get 0.4. So 0.2 plus 0.2 is 0.4. H is our step length. So in this way, we can create the whole table of x. Simultaneously, we can calculate yi's and we can fill this table. Now, the last column is of f of xy. If you wish, you can make a table like this, or else you can just make a table of x and y. So on the similar pattern, I have calculated y3. Y3 is nothing but my y at 0.6. So you can see in this table, it is coming out to be 1.952. Now y4 is y at 0.8, which is coming out to be 2.4624. And lastly, y5. What is y5? y5 is y4 plus h times f of x4 comma y4. When I calculated it, it is coming out to be 3.11488. This is my value of y at 1. This is what we have to find out in the question. What is the value of y at x is equal to 1? So this is the approximate value. If we wish to calculate it at the 3 or the 4 decimal places, so this would be 3.1149 approximately. So like this, we can apply Euler's method and we can solve the question. So in the next lecture, we will be doing one more question of Euler's method. So thank you so much.